Okay, welcome back to smarthelping.com. It is Wednesday, December 21st, 2016. And today, we got some math and how to apply R as well as the least squared regression line model in order to visualize raw data in a more smooth fashion. So this Excel sheet allows you to take any data set and try to compare two things and then show that comparison in a nice way. So with R, you always have two things you're testing correlation, and you can do this with any two things. So here I just did a real simple scenario, and I did length that a candle burns in hours, and then the wax left. And this is not real data. I just kind of made up the numbers. But obviously, the longer it burns, the less weight there is left because assuming the candle is used up and it weighs less. Or you could do percentage of the jar left or whatever. So you can see how this general correlation analysis could be applied between two different things for all types of scenarios, millions of different scenarios. All you need is an X set of data, and based on whatever you're measuring for that, you have a Y output. So X is the input, Y is the output, and you can measure as long as those two data pieces are connected for whatever way, you can do this analysis. So the first way is a quick quicker with Excel functions. So first we just figure out the correlation. So you got your correlate function in Excel, and you just choose array 1 and 2. Doesn't matter what order. And then it spits out this number, negative 0.89. Quick thing on correlation, it goes from -1 to +1. +1 would be a very strong positive correlation, meaning as say the candle burn goes up, the amount of wax left goes up. That would be closer to 1. And the better the data is correlated, for example, the more closely Y responds to a move in X, the closer to 1 it's going to be if it's going in that positive direction. If it's negative, like we have here, the closer to -1, the stronger the correlation is. So we have, our outputs going down as our X's are going up. And these could be in any order. They don't have to be in order in your raw data set to still get the same correlation figure. As you can see, if I change this to say, if I move the 3.5 and 650 up here, and then say the 1.2 and 1200 here, you can see the negative 0.89 still stays the same. Same calculation. So that's the simple way. And these are to get the least squared line, which basically that's just a regression line that has the least amount of space in between the dots. So if you're looking at this data on a scatter plot, for example this, and you're trying to draw a line, the least squared line is going to be the line that best represents this data in a linear fashion. And you also got your y equals mx plus b formula down here. This is actually, I think Excel, you can set, I was messing with this thing, you can set it to be a best fit line, or you can do all kinds of different lines. So this actually is going to be what we're calculating manually in all this data here. So you can see we're going to actually calculate the slope, where our y-axis crosses, which is b, and then from those things we can actually test an input and then get an output. So let's go back to this correlation. I've also added in the Excel sheet a manual calculation of R. And that, you take the x times the y, and you got that, and then you total it. Well, first you total the x's, total the y's, then you do x times y, total. You do x squared, total, and then y squared, each one in a total. Once you have this, you can move down here, and you got, your number of occurrences, and I've kind of laid out here in pseudocode some steps that you take, you're using these numbers, basically these bottom numbers, to get these calculations, and then you're doing some more calculations down here, and finally the end result is you subtract this one and this one, and you get our negative 0.89, which is what we get up here. So good, that shows that okay, the correlation function is working. Now if you don't want to do this manual step for R, or if you're able to do a simpler one, you could just use the correlation function. But for whatever reason, your software, or I don't know, you might just want to be able to do the manual part as well. So that explains that. Then we have average of the y's, the standard deviation of the y's, the average of the x's, and the standard deviation of the x's. Now once you have those averages and standard deviations, we can calculate our slope, which is simply going to be our output standard deviation divided by our input standard deviation. So the standard deviation of y divided by the standard deviation of x multiplied by r, which is the correlation. And that gives you the slope of this data series, which is negative 144.18. If you look at this, you can see the slope is auto-calculated at negative 144.18. Okay, so good, that's right. And then we got our x-axis cross. You simply take the slope times the average of the input, and then that value you're subtracting from the average of the outputs. So 721.82 minus 4.35 times negative 144, and we get a positive 1349. So it's basically telling you what the difference is if you take the slope times the average of the inputs, and then you want to know the difference between that and the average of your output, which is 1349. If you go on our thing here, you can see, well, 1349, if you keep drawing this line up, that's where it will cross here. And you can see that's numbers right here too. So we have that. Now we solve for y, so you can put in any x value, and then it will give you a predicted y value. So it's not going to match your data set exactly unless it's a 1.0 correlation. So if you see, we plugged in say 2.3 here, we get 1018. You can see it's a little bit different here, but then you can use this for any value. So we could go up to 15 hours. Well, it's going to be negative because that's going to say if you keep going on there's no candle left. You go down to 4, you get 773. Now just to demonstrate, you can see if this went 1, 2, 3, and then let's say this went 11, 10, down to 1, you see the correlation is exactly -1. So now whatever I put into my input will exactly match the output that you see here and going on. So if I put 11 in here, you get 1. If I put 1 in here, it's 11. You can see this is updated down here as well, and it's -1 matches that, and then our slope is -1, our cross is 12. That will show up here. Formula's kind of hidden. Let me move it. But see, -1. Well, that's just not showing up since it's a 1. Plus 12. And then, so that's kind of just to show you just really demonstrate what the correlation means and what that means for you plugging in your values. Now we're going to keep going further here. Let me put back our first set of values. So we have these kind of messy numbers, and we want to test a set range of inputs and see what the output looks like. Maybe we don't want to test exactly what the raw data is. We want to use the raw data, and based on the correlation of them, we want to predict what might happen with other data. So here we have, our duration. We're going 9 to negative, let's do 10. Let's start at 10 hours. Or, you know what, let's go 1, 2. It's easier. So let's say we just wanted to see, alright, well, what does it look like from a smooth amount 1 hour to 11 hours? Or let's go by half an hour. This is what the function allows you to do. Oh. Within the nice thing of Excel is you could just use formulas, and you've defined you've got your definitions that you need to use and your input here. So you test all these inputs, you run it through this, and then you're getting a different Y output for every one. So burn duration 1, you got 1200 left. 6 hours, you got 44 left. And you can see this nice slope visually, and this is all based on what your data set is telling you in the XY, in how much they're correlated. And we have our scatter plot here. So this is just a real quick sample, but you can use this. There's so many ways, so many places you can go with this, and all you need is just that raw data to test against. So this tool is really good to explain to people, or explain to your developers or whoever, how the logic works, and then you can be creative in what kind of data you're using and what you want to do to it in order to visualize different things. So that's all I got for you today. This is smarthelping.com, and if you want to download the Excel sheet, follow the link in the description box below. It will take you to my blog page, where I will explain basically everything I just told you here, and then I will sell this to you for well, the price could change, but it's going to be cheap. I mean, probably $20 or something, or $15. But the main value for me is that if you need consulting help or help using this in your specific situation, you can hire me out. My hourly rate fluxes depending on how busy I am. It could be as low as 30, as high as 50, and then it depends on what you need and how many hours. So I hope this helps. Probably will help a lot of people trying to do correlation analysis and visuals on that. Alright, have a great day.